We extend our discussion on heat equation to the last case, where the heated rod with non-zero temperatures at endpoints. It means that at the boundary condition, when x equals to 0 and x equals to L, the temperature is not zero. It has values. So for this case, solution of the PDE with heated rod with non-zero temperatures at endpoints, given that boundary condition is this and initial condition is this, has the short solution of UST equals to T naught, where T naught is taken from the boundary condition and TL is also taken from the boundary condition when x is equals to L minus T naught times with x over L plus the summation of dn times sine n pi x over L times with the exponential of negative n squared pi squared k squared t over L squared, where dn are the Fourier sine series coefficients given by this equation. So it means that you have to find the Fourier sine series coefficients first. Once you solve this, you substitute into this summation and you will get the solution of UST, where this is the solution of this PDE. Now let us try this example using the method of separation of variables to solve the initial boundary value problems. Given ut equals to 4 uxx, where 4 is, so now I will write down all the important terms. So we have k squared equals to 4, and the length of x-axis is from 0 up to 5, so L is equals to 5. And we have the boundary condition and the initial condition, where when x equals to 0, the boundary condition is equals to 3, and when x equals to 5, it is equals to 10. Okay, so 3 here is the T naught and 10 is TL. Okay, another things is because the value of the endpoints are not equals to 0. So we consider this as T naught and TL. Okay, and the last one is the initial condition. When T is equals to 0, the temperature is equals to a function of 4 plus x, where this is fx. So we can write down fx is equals to 4 plus x, and we have T naught which is equals to 3 and TL with equals to 10. So now we can find the Fourier sine coefficient of dn, where dn is equals to 2 over L times with integration from 0 up to L fx, which is 4 plus x minus with T naught minus with TL minus T naught, which is 7x over 5 times with sine n pi x over L. So simplifying this equation, we will get this 1 minus 2 over 5x sine n pi x. So we can solve this using the tabular method. So integrate sign, you will get negative cos n pi x over 5 divided by n pi over 5. So I just rearrange this, we will get 5 over n pi times with cos n pi x over 5. And the last one is 0, so this will be negative 25 n square pi square sine n pi x over 5. So we can proceed by substituting the integration into dn, where dn is equals to 2 over 5, where this will be negative 5 times with 1 minus 2 over 5x divided by n pi, and then minus with 25 times 2 divided by 5, we have 10 over n square pi square sine n pi x over 5, where the integration is, where the limit is from 0 to 5. So substitute x with 5, we get 1 minus 2, negative 1, so we have 5 over n pi cos n pi minus 10 over sine n pi minus with and the last one is minus 10 sine 0. So substitute cos n pi, which we get negative 1 to the power of n. Sine n pi is equals to 0, cos 0 is equals to 1, sine 0 is equals to 0. So we have 2 over 5 times with 5 over n pi plus 5 over n pi, or we can take out 5 over n pi, we can write it as 2 over n pi 1 plus negative 1 to the power of n. Or this can be simplified as, so when n is odd number, we will get 0, and when n is even number, we will get 1 plus 1, which is 4 over n pi, where n equals to 2, 4, 6. Now we can find uxt, where uxt is equals to t naught plus tl minus t naught times with x divided by 5 plus the summation of dn times with sine n pi x over l e to the power of negative n square pi square k square is equals to 4d divided by l square, which is 25. So we expand this, we get d1 sine n is equals to 1. So we have pi x over 5 e to the power of negative 1 square pi square times 4d divided by 25 plus, when n is equals to 2, when n is equals to 3, when n is equals to 4, and so on. So now we can substitute d1, d2 up until d4 into the equation, where we know that when n is equal and when n is odd number, d1 is equals to 0. So this will be 3 plus 7x over 5 plus 0 plus d2, where d2 is equals to 4 over 2 pi plus 4 over d3 is 0, so now n is equals to 4, 4 plus 4 over 4 pi sine 4 pi x over 5 to the power of negative 4 squared pi squared 4t divided by 25. Or we can simplify this, and you notice that this series is increasing with 2, this part and this part, where when it is increasing with 2, where this is an even number, so you can rewrite this as, or we can represent it as, so first we take out 4 over pi, and the summation will be 1 over 2n, because this is even number, every even number, sine 2n pi x over 5 e to the power of negative 2n squared pi squared times 4t divided by 25. So this is the solution for the PDE. So this is the summary of heat equation for three different cases. This is for the first cases where the zero temperature at endpoints, and this one is for the second cases where the endpoints are insulated, and the last one is the heated rod with non-zero temperature at endpoints. So what is important for heat equation is that you need to identify the problem and which category does the problem falls into.